and C. Okay. Power is the rate at which energy is transferred. If I said to you, I'm going to give you £1 million pounds, you'd be happy about that, yes? But if I said I was going to give it to you at the rate of 1 penny every 1,000 years, would you be happy with that?
No.
Oh, I can lift 1,000 kilograms. Did you know that?
No.
Well, I can lift 1 kilogram 1,000 times, which is 1,000 kilograms, right?
Yeah.
So sometimes the rate at which something happens is more important than the actual happening. In electricity, sometimes the amount of power transferred, amount of energy transferred every second is more important than knowing the total amount of energy. The last lesson that we did, we looked at the equation energy is equal to voltage times current times time. That told us the total amount of energy that was transferred in the circuit. Today, we're going to be looking at a different equation which tells us the amount of energy transferred per second, the amount of power. Just reading it from the text from the whiteboard, power is the amount of energy transferred in a second. Electrons are the carriers of energy. If I was to draw this up on the board, I was to say it was a 3-volt cell. This is 1 coulomb of charge. How many joules is going to be inside that coulomb?
1, 3.
It's a 3-volt cell. It's 1 coulomb of charge. It's going to be 3 joules inside that coulomb. Electrons carry energy in packets. What's a packet of electrons called?
Coulomb.
There we go. Electrons are the carriers of energy. Power is therefore the amount of electrons passing energy to the component every second. The amount of energy per electron passing energy to the component every second. And just remember that the word component would be lamp, motor, and diode, machine, sound thing, buzzer, that's what the word is. Any kind of component of energy transferred to it. Current is the amount of electrons passing a point in the circuit per second. Current is the coulomb per second. The current in a circuit depends on the amount of resistance in the circuit and the push from the cell. The current depends on the voltage. What we're doing today is we're squeezing together 2 ideas. One idea is this. That current is the amount of coulombs every second. Current is the charge per unit time. Current is the coulombs per second. We also know that voltage is the amount of energy for every coulomb. Remember that per means for every. Voltage is the amount of joules per coulomb of charge. Power is the amount of energy per unit time. Did not mean to delete that. Voltage is the joule per coulomb. Current is the coulomb per second. If I have got 3 volts, how many joules per coulomb is that? 3. So 3 volts is equal to 3 joules for every 1 coulomb. And if I've got a current of 1 amp, how many coulombs per second do I have? 1. I have 1 coulomb for every 1 second. If power is the amount of energy transferred per second, how many joules are being transferred per second in this example? There are 3 joules for every coulomb, and there's 1 coulomb for every second. 3 joules per coulomb, 1 coulomb per second. 3 joules per coulomb per second. How many joules per second are being transferred? 3. I have got 3 joules per second. Instead of saying joules per second, I'll say 3 watts. The units for power are watt. W-A-T-T. A slightly different example. If I have got 2 volts, how many joules per coulomb would that be? 2. If I have got 10 amps, how many coulombs per second would I have? 10. What did I say it was? How many volts?
10. was 10 amps. You said
10 amps. So 10 amps is equal to how many coulombs per second? 10 coulombs per second. How much voltage was it? 2? 2 volts, yeah? So 2 volts is equal to 2 joules per second. Okay. How many joules per second are being transferred? I've got 2 joules for every coulomb. I've got 10 coulombs every second. That's the same as how many joules per second? 2 joules per coulomb. 10 coulombs in total. So count up in your head how many joules there are. 2 joules per coulomb, 10 coulombs per second. How many joules per second will that be? 20 joules per second, and the unit of that is?
20 watts.
Yeah, 20 what?
Watt.
Pardon? Pardon. The other way that we can do this, of course, is with a simple calculation. Power is energy divided by time, but also power is current multiplied by voltage. The easy way of doing this, rather than worrying about figuring it out in your head, is just looking at the number that we have for voltage. This is 10 amps. This is 2 volts. Do we get the same amount of watts just multiplying the current by the voltage? Yeah. So we've got 2 equations up there. Power is energy divided by time. Power is current multiplied by voltage. Now I want you to go. Okay. Now you're going to do an icon replace. And try and figure out what each of those icons are referring to. So you can get the definitions and the wording that you need. I need you all to look at the back wall, please. Seriously. Because the people who are at home, you can look here are the answers. Press pause and play again. Okay. Wait, look at the back wall again. Thank you. Right. Icon replace in your booklets. Oh wait, hang on. Yes, no, we're not going to. We're just going to do this very quickly, okay? Goodness. Yeah, brilliant. All right, okay. For at home, this is the table that you're going to need, and this is the table that you're going to need. Don't worry about pi squared times r just for the time being to do this task. All right, so pause and do this task. Everyone look at the back wall. And here are the answers to these questions. Back wall! This is the get it, go for it. Keep staring. That's a really interesting blind right there in the middle, everybody. You at home, pause. Back wall! And here are the answers for everybody at home. The go for it was especially difficult. It's target 9. So didn't get it right. Don't worry. Don't panic. All right. And then you'll be ready for next week's lesson. And that's been recorded for everyone to know. It's all right if you don't mind everyone knowing that you just drooled everywhere.